Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone, it's me again, Mostafa Shaikhoun, and this is ELV Systems Fundamentals course. In the previous videos we talked about the principles of electricity, then we learned solar power system. Today we're gonna learn data network structure. Let's start. The data network structure system we use it to transfer data between different devices within a building or facility. These devices could be computers, could be printers, cameras, audio system, servers, and more. For example, if I have almost 100 employees, is it logic to get 100 printer for each one? No. So I get one printer and all the employees can share it. So that means sharing of resources. And everywhere now has data system structure. For example, in my home, I have data network structure. In my company, I have data network structure. In the school, we have data network structure. In the hotel, they have data network structure. So everywhere now depend or rely on data network structure to make sharing of resources. When you start to study data network structure system or networking systems, you have two abbreviations you should understand. The first one is the LAN. LAN is abbreviation or shortcut for local area network. What does mean LAN? LAN is a network within one building, within one facility, within one geographical site. This LAN could be content of routers, switches, printers, servers, computers, cameras, telephones. So any internal network, we call it LAN. And another abbreviation is WAN, abbreviation for wide area network. And this is, we can say, the internet, the web, and we can say that that is the internet network. It's international network. It's connected all the world together. So if I have one network inside my home, inside my company, inside my facility, I call it LAN, internal network. But if I need to go outside for the internet, now you are in WAN. How can I connect the WAN network from my LAN? It's very simple. You have to get one router, and through the router you're gonna go outside to the WAN. For example, if I am living here in United Arab Emirates and I want to send a file PDF for someone, he is located in Cairo in Egypt. So how can I transfer this file? Of course, I will transfer it through the WAN. It's the file gonna go out from my LAN, from my company, from my apartment, and take the internet network to reach another destination that's in Cairo or in Egypt. So now I know how to use the WAN. So what is the WAN gateway for you? The WAN gateway for you, it's gonna be the router. But if you are still inside the network using the switch to connect to the CCTV inside the facility, to connect to the printer, to connect to the computers, to connect to the telephones, so all of this we call it LAN. But once you go out through the router to somewhere else, another city, another country, another area, that's called a WAN. Inshallah, when you get a big project, you're gonna face two abbreviation in the site. First one is MDF and second one is IDF. MDF stand for main distribution frame and IDF stand for intermediate distribution frame. What does mean these two abbreviation? Let's imagine that this square is my project. Your project is a college, school, a hospital, big company, big facility, whatever. So this is my project. And once you go inside the project, you need to make one data center. I talked to you about that before. I told you that when you get big project, you need to make a power calculation, right? So power calculation of what? Of the devices you're gonna use in ELV system, like switches, routers, gateways, firewalls, MVRs, recorders, and so on. So all of these devices gonna be located in one room. This room we call it data center or MDF, main distribution frame. So here, as we say, internet coming from ISP abbreviation for Internet Service Provider. It's go inside my site or my project to MDF, the main distribution frame. This main distribution frame, it has the main switch, the core switch, the routers, and it has data rack, same like this. And from this MDF, and this MDF usually located in the ground floor. This MDF usually located in the project in the ground floor. From this MDF, we're gonna take uplinks to IDF. IDF, it's same like MDF but smaller. IDF abbreviation for Intermediate Distribution Frame, and it's a smaller room, or maybe gonna be a rack, wall-mounted rack. We're gonna connect to all the IDFs. Here, as we see, first floor he has one IDF, second floor one more IDF, third floor one more IDF. And this IDF all connect to the MDF by uplinks. We're gonna know how to make uplinks بعدين inshallah. So why is they making in the building or big project MDF and IDF? They could cancel the IDF, right? No, they couldn't cancel the IDF because this IDF is same like a shortcut to MDF. For example, if I have computers, I have telephones, I have access point, Wi-Fi access point, I have CCTV, and all these devices is located in the third floor. And from third floor to ground floor over 300 meter or 400 meter. It's not possible to connect all these devices to the MDF, the switch in MDF in the ground floor. So what I have to do, I have to divide the project into IDFs, and I connect all the third floor devices to the IDF that located in the third floor, and I take one uplink. This uplink usually will be fiber optic, as we're gonna know now. So I connect all the devices to a small cabinet or a small rack in each floor, and from each IDF I connect with uplink to MDF. In the network world, or in the network system, we have two types of components. We have component called active component and passive component. What does mean active component? Active component is everything needs power and configuration to work. Same like routers. The router I need to feed to power on, right? The switch I need to feed with power to power on. The servers, BDU, UPS, and I need to these devices I need to make some configuration or programming, right? But the passive component, no need to get powered on and no need to get configured by anyone. Same like cables, batch cord, patch panel, cable manager, approach panel, the RG connectors, and the cabinet. We're gonna check everything now. We're gonna study everything here. So we have two types of component: active component and passive component. Also, we cannot start to learning network system without these expressions. We have here something called IP. Of course, you heard about it before. So IP is abbreviation for Internet Protocol. Any device wants to use the network, it should use IP. The IP same like your telephone number or your home address. Exactly. So your phone has IP to be able to use the network. Your computer has IP to be able to use the network, and any smart devices now has IP. Okay, so what does mean MAC? MAC abbreviation for Media Access Control. This is also address, but it's unique address, and this address is assigned to the device's network interface card. Any smart device has NIC, network interface card, and there is no NIC in the world with the same MAC. The IP we can change, but the MAC address we cannot change. Maybe you can find two devices has the same IP. It's local IP, but you cannot never ever find two devices with the same MAC address. We have here many type of IP addresses. First one is the private IP. This IP you use it in the LAN, inside your LAN. For example, your mobile cell phone IP and your smart TV IP. So this IP, of course, you can find it with someone else, with your neighbor, with your friends, and anyone else can use the same IP. But he is in his network, and you are in your network. And public IP, this IP that you're gonna use to go outside of your LAN. For example, when you need to text someone or send the file for someone, he's outside of your city, outside of your country, so your device, if mobile or laptop, gonna go out for the network with the public IP. The dynamic IP, this dynamic IP, it's changed regularly. Once you restart your device, it will take another IP. And this dynamic IP, it's very useful in the network, because the devices, if you have many devices and you don't want to give a static IP or a specific IP, they will take automatically IP from the router. So this IP is always changing. And the static IP, it will never change. Once you give device in the network static IP, it will never change even after restart. So this was the IP. Let's talk about the routers. I told you before, the router is your gateway to the outside world or outside the network. If you want to go outside of your LAN or your apartment or your company, you need to use the router, and you cannot go out without router, right? As we see here, this is the LAN. I have one switch here. I have a server, printers, computers. All of them are connected to the switch. And from the switch, there is one uplink to the router. And from the router to the WAN, wide area network. So the router is the gateway that passes data between one or more local area networks. And the router, of course, using the IP protocol. As I told you before, if you want to go outside, you have to go outside with public IP. And I told you that the IP is same like your phone number or like your home address. If you want to talk to someone, you're gonna call him by phone number. If you want to go somewhere, you're gonna go there by the address. And here in United Arab Emirates, once you call Etisalat or ISP, internet service provider, they will come to you, they will pull one cable. We call this cable fiber cable, we're gonna know it later. And they're gonna give you two devices. First one is the modem, and this modem is connected to ISP by fiber cable. And there is one batch cord, we will see later, connected to the router. And this router could be a Wi-Fi access point router. So if you want to connect your LAN to the WAN, you should connect your switch to the router. Do not never ever connect your switch to the modem, because you don't have any business with the modem, because this modem between Etisalat and you. If you want these devices will be online, you should collect it in one switch and from the switch to the router. And this is I think exactly the shape of the routers and the modem that comes from Etisalat in United Arab Emirates. The switch. What does mean switch? Why will you switch? The switch allow you to connect more than two devices together. For example, if I have two laptops or two computers, or I have many camera, I need to connect to all this one together. How I connect it? I connect it to the switch. So the switch is something to gathering all the devices that works with IP. Here I show you I have server, printers, laptop, computers, cameras, and so on. We need to make all of this one network. We need to make it LAN. How can we make it LAN? We should connect it to the switch, right? We connect it to the switch before we go outside of the network. So that is the switch, and the switch is understanding the MAC address. It works with MAC address. We have layer 3 switch, it works with IP, but this is not our topic now, not our scope now. So if you want to make local area network, if you want to make internal network or LAN, first thing you have to think about it is the switch. We have two types of switch, managed switch and unmanaged switch. The managed switch, you can make programming for the ports. We're not gonna study that today, but you have to know that there is managed switch, you can make programming for VLAN ports, you can divide these ports, and unmanaged, once you connect it, it's gonna be working. Also we have BOE switch and non-BOE switch. BOE switch, BOE abbreviation for power over Ethernet, means if I have IP camera, and nowadays all the cameras are working with BOE. If I have IP camera and connected to the switch, خلاص, no need to connect power adapter for the camera, because the same cable that connecting the camera to the switch, it's gonna transfer data and feed the camera with a power. So BOE switch gonna give the devices power and transfer data. Okay, I have in the market Ethernet switch, fast Ethernet switch, Giga Ethernet switch. What does mean that? This is how the switch transfer the data. 10 megabit per second or 100 megabit per second or 1000 megabit per second. My advice, when you buy a switch, make sure that this switch is Giga switch. You're gonna find it, it's written in the box, Giga switch. So this is the fastest one here. The server. Simply, the server is a computer or system that provide resources, data, services, or programs, or to other computers or clients over the network. So the server is a simple computer inside the network, the local area network, inside my company, inside my home, inside my facility, and we use it to share the resources. We share data, we share services, we share program. It's acting like a central point. Okay, it's a central point to sharing the information, and it's a high specs, means it's a computer but with high RAMs, with high processor, with high storage, with high capacity, with bigger case. So it's a computer, but it's a huge computer. We put it in the network to be a central point to sharing the resources. The BDU abbreviation for power distribution unit, and we know that everybody know what does mean BDU. It has multiple outputs for power, so we use it to connect to all the devices to make it powered on. Simply, this is the BDU. UPS, uninterrupted power supply. It's a device. Once I have failure in the power, it's gonna working as a backup, because it has inside batteries. It's content of batteries. That batteries storing the power to use it later. Once I have power failure, this UPS gonna feed my devices. It's simply same like the power bank. When your cell phone or your laptop or your tablet gonna switch off, you gonna connect it to the power bank to feed it again. So UPS, same like the power bank. We use it in the network to connect the devices here. Once I have failure in the power, it's gonna power on my devices for sometimes. It depends on the kV of the UPS. Let's get know how we connect the devices inside the network. The cables. The cables is the structure. I have two types of cables: copper cables and fiber optic cables. The copper cables, the conductor made of copper, but the fiber optic cables, the conductor or the core, it's made of glass. It's pure glass, so it's transfer the data through the light. In copper cables, I have UTP and STP. UTP abbreviation for unshielded twisted pair, and STP is shielded twisted pair. We're gonna see that in the next slide. So the copper cables could be UTP, could be STP, and the categories start from Cat5, Cat5e, Cat6, Cat6a, Cat7. Okay, all of them from outside the same shape. So Cat5, same like Cat6, same like Cat6a, but the different in the coating, different in the core or the conductor, the different in the percentage of the copper in the conductor. The fiber optic cable, I have two types of cable. I have multi-mode fiber optic cable and I have single mode fiber optic cable. So quickly, a copper cable, it could be UTP or STP, and the fiber optic cable, it could be single mode or multi-mode. The UTP abbreviation for unshielded twisted pair, same like this cable. This one in the top is UTP, unshielded, but the STP is shielded twisted pair, and this one is the STP. As you see here, there is foil slides around each pair. That's called STP. And these are two types of twisted pair cables we use in network. So when I need to connect the devices in the network with copper cable, my cables could be UTP or STP. Let's see quickly what the difference between the categories. For example, before the Cat5, it was data rate up to 100 MB per second, and Cat5e, it was transferring, or the data rate was 1 GB per second. The Cat6 can transfer up to 10 GB per second for 100 meter. Cat6a also can transfer, or the data rate, it's gonna be up to 10 GB per second, and the Cat7 also can transfer by 10 GB per second for 100 meter. All of them are twisted pair. What does mean twisted pair? This shape, this twisted. Why the cable are twisted? To reduce the noise, and attenuation in the signals. And as I told you before, when you buy the switch, make sure that it's a Giga switch, not Ethernet, not fast Ethernet, because of the data rate. So, for example, if you have Cat5 cable and you have Giga switch, the data rate, it's gonna be up to the lower component. So the data rate will be 100 megabit per second. But if you get Cat5e or Cat6, Cat6a, Cat7 with the switch that working with Giga, data rate, it's gonna be up to 1 GB per second. So when you build your network, make sure that of the components all should be suitable for each other. Don't go to buy Giga switch and the network cables gonna be Cat5. So the data rate will be according to the lower component. We have here a quick comparison between UTP and STP. Here in the structure, the UTP is cable with wires twisted together. This is UTP, but the STP is twisted pair cable enclosed in foil and shield, as we see here. The cost, the UTP cheaper than the STP, of course, because of the foil. Bonding and grounding of cable. Here in the UTP, no need to make grounding, but the STP we need because of the foil. Actually, we don't do any grounding for any cables. The crosstalk is high in UTP because it has no shield, it has interference, it's easy to interference, it's easy to get noise. But here in the STP, it's low because of the foil that enclosed for the twisted. The termination, it's easy to terminate and save the time. Not easy to take a long time and take the long time. Once you crimp it, we're gonna know how to crimp. This STP takes time to crimp because it's not flexible enough. And we use this UTP in the small project, indoor project, somewhere we has no interference, or we have no high voltage systems nearby my systems. But the STP, we use it in the large project to keep data safe from noise and attenuation. The fiber optic cable. The fiber optic cables is a flexible glass or pure plastic fiber that can transmit light from one end to the other. So here the core or the conductor is not copper, a glass, pure glass or pure plastic. Also we can transmit or transfer the data for long distance. We said before we can transfer the data by the STB or UTB 100 meter, but here the data can travel for kilometers with higher bandwidths. We said before we have multi-mode and single mode. This is the multi-mode cable, data transfer like a wave here, but in the single mode it's going straight على طول. Here in this picture we can see the core that made of glass or pure plastic and cladding and the plastic jacket. Also we have indoor and outdoor. We have indoor fiber optic cable, we have outdoor fiber optic cable. And when we make a joint, we are not making a traditional joint because it's a glass. How we can connect the cables or we make joint in that one? We're using sublicing machine. We do sublicing, and you can see here the sublicing machine. We put one end here and the other here. We close this cover, then we program the machine to make sublicing. So we use this one to transfer the data faster and for long distance. We have one element in the network called batch cord. This is a very important element or component. This a cable. It could be fiber, it could be copper. We use it to connect the devices in the network, or we use it to connect the devices in the data rack. For example, I need to connect the routers with switch, so I have to connect it through the patch cord. Most of the devices or all the devices we can connect with the copper patch cord, and some devices we need the high transmit, we use fiber optics. Also we can see here another usage of the patch cord. We connect our laptops or PCs to the faceplate in the wall via the patch cord. So patch cord is a short cable. We use it to connect the devices to each others. As you see here, this is data socket in the wall, and from the data socket we take the patch cord to the computer. We can take the patch cord to the phone. We can take the patch cord to access point. We can take the patch cord to the printer. We can take the patch cord to the server. Okay, and here as we see, this is the data rack. We have here server, we have router, and from router we connect with the switch with the patch cord, and the switch to the patch panel with the patch cord. I need to tell you one thing. When you make the infrastructure and when you start building your network, the network starts from the data rack. This data rack, as I told you before, it's located in the IDF or MDF or the data center room. From the room we pull pipes or we pull trays inside the slab, inside the concrete slab and the wall. As you see here, the yellow line is conduit. So we put conduits or trays or rack from the data rack to the point. Here we have, as we say, data socket point or data point outlet in the wall. This data point outlet, it's connected to the rack, and here it's connected directly to the patch panel. We're gonna see what does mean patch panel later. So this data outlet, it's connected to the patch panel, and from the patch panel to the switch. Here's the patch panel. The patch panel usually used to manage and organize various types of Ethernet cable. As you see here in the picture, this is the patch panel. From front we connect the patch panel to the switches with patch cord, and from the back here like this we connect it to the data outlet point, as you see here. For example, I can connect the patch panel directly to the data outlet. This data outlet, I can connect to phone, I can connect to PC, I can connect to printer, I can connect camera. Okay, this is the data outlets in the wall, and this is the conduit inside the concrete and slabs going to the data rack through the patch panel from the back. And in front of the patch panel we use the patch cord to connect our devices. We have another type of patch panel, that fiber optic patch panel. The same idea, but this to connect the fiber optics cable. We have one more element here, it's called cable manager or brush panel. We use this brush panel and cable manager to manage the cables inside the cabinet. As you see here, I have the patch panel. Here the cable go inside to be connected to the switch, and the cable manager here I can put the cables here. So between the patch panel and the switch I have to put cable manager or brush panel to hide and organize the cables. Let's talk about the jacks and the outlets. To terminate the Cat6 cable you need to use RJ45 socket, as you see here. This is for the Cat6, and the telephone sometimes used RJ11, as you see here. This connector, as you see here, it's called Keystone RJ45. After we connect our cable here in the Keystone, we push it to the faceplate. That faceplate we install it in the wall. See here, this faceplate, that one, and in the back or behind the faceplate there is the terminal. It's Keystone RJ45. So the cable came from the rack, from the patch panel, to the slab, to the wall, to the concrete, to the faceplate through this Keystone connector. So now you know what is behind the scene. And I have one outlet, it's called floor mount outlet. This one we put it in the ground under the desks, not wall mount. This is floor mount outlet. Here I have the sequence of crimping or terminating the RJ45. We are following the standard B. The standard B says white, orange, orange, white, green, blue, white, blue, green, white, brown, brown. The both sides should be the same sequence. You don't have to do the type B, one terminal or one side and another side the type A. If you're gonna follow this one, you should make the both sides of the cable the same type, but everybody working with the type B. Here also, if you can see the Keystone, they make you guide or reference to follow which type you're gonna use. Type A, you have to follow if you have to follow type A, so this one gonna be white, green, green, white, blue, blue. But the sequence B that we are agree about it, it's called this white, orange, orange, white, blue, blue, as he did here. So here he followed the type B, standard B. I put here some links. It will direct you to the YouTube to see how to make crimping. Also here I have some tools. It's useful tools. It's mandatory tools to work in the data network structure. This device called cable tracer. I use it to trace and find and test the cable inside the network. This is crimping machine. This crimping machine, we use it to crimp this RJ. After I put the sequence inside the RJ, I put the RJ inside the crimping machine. I will tighten it, it will crimp and make termination. This one is punch down tool. Punch down tool, I use it here to punch down the cable inside these holes. You're gonna see all of this in the links. This is the cable manager. I use it to organize the cable while I make it or I dress it for the rack. Here this rack, when I do the rack, there is too much cables coming inside. So to make this cable going straight inside, I have to use this cable manager to make it straight together. And this fishing or pulling cable, some people say spring. This we use it to pull the cable inside the conduits. For example, I need to pull the cable from this point to the rack. So I have here the yellow line is a conduit, 20 milli conduit, 25 mm conduit. So I have to put the fishing wire first from one side. For example, from here, it will go inside and come from here. Once I get the spring or the fishing wire, I try to put my wire and pull it back to the rack. And that device is labeling machine. I have to make numbering to be organized. I have to make numbering to know which cable is that. Here let's talk about the data rack cabinet. It's a cabinet, as you see here. I use it to housing the IT equipment. It's protecting my devices and make it organized. And that track you can find it in the market described by U. What does mean U? For example, the switch needs one U space inside the rack. The patch panel need one U. The brush panel need one U. The routers need one U. So when you describe the data rack cabinet, you have to determine how many U you need. For example, if you have one brush panel, one patch panel, one switch, one router, so this is 4. So you have to get cabinet more than 4U. To be in safe side, you have to multiply by 1.5. So if you need cabinet 4U, you have to multiply by 1.5. So the suitable cabinet for one patch panel, one brush panel, one switch, one router is 6U. That's called cable tray and trunking. Sometimes we are not using the conduit. Sometimes we cannot leave the cables flying in the air. So we pulling the cable and we lie the cables on something like that. We call it that tray. This is cable tray. It's a structure we use to support and organize electrical cables. They provide safe, organized way to manage cables, and it's called trunking. Trunking, we use it sometimes to make external or provision for the cables. If خلاص we don't have any hidden conduit and we have to pull cable, we cannot leave it like this. So we put trunking like this, okay, to protect the cable and make it safe. Here the conduits. We have many types of conduits. The conduits are metal or plastic tubes that serve as a protective channel for electrical wiring in buildings and structure. As we see here, this is called conduits. We have many types in the market. We have the PVC conduits like this. The plastic one we call it PVC. We have EMT, electrical metallic tube. This one EMT, this is the most strong one. We have FMC, flexible metal conduit. This one is FMC. We have the PE, pliable conduits. That one it's called pliable conduits. So you have to know the types of conduits in the market. This is the most stronger one. This is for indoor and outdoor, but this one the most weak one. We cannot use it outdoor. This one we can use it outdoor. This one we cannot use it outdoor because of it's not weatherproof. So let's see the steps. And if you wanna implement data network project, you have to follow these steps. First one is to receive the shop drawing. The consultant, the engineer gonna give you drawings. You have to determine, and everything is shown on the drawings because you don't need to ask too much questions. Then you have to determine the point, location and equipment on the drawings. Start to make piping, conduits and tray. Then you have to pull the cables and classifying the cables with the label machine that I show you here. Then installing the outlets and patch panels. These outlets here in the walls and the patch panel inside the data rack cabinet. Let me bring this one. After that, after you pull cables here, after you pull cables from here to here, from the patch panel to the data outlets, you have to test the cables. You have to test the termination you did. How you tested the termination you did? With the cable tester. Then you have to connect the devices to each other, the patch panel to the switch to the routers and servers and recorders. And you have to program the devices that manage it. Same like managed switch, the router, the server, the recorders. After you finish everything, you have to make as-built drawing. That as-built drawing, it's a kind of AutoCAD drawings, but it shows what have you done exactly in the drawings. So you receive drawings and you will do your work. After you do your work, so there is one shop drawings that you will get from the office or from the consultant, but you cannot implement exactly like what the the office mentioned in the drawing. So there should be some difference. No problem. But after you finish, you have to make another drawing. Let's call it as built drawing to show everything have you done exactly. Q&A. First question, what does mean data system? The data system is an internal network. It's LAN, local area network. We used to connect computers, printers, IP camera, the devices to each other. Why we connect it to each other? We make sharing of resources. We exchange data. What is the difference between Cat5e and the Cat6 cable? We mentioned before, we said Cat5 supports speed up to 1 GB over distance 100 meter, but Wi-Fi 6 supports speed up to 10 GB over distance up to 55 meter, and it's better solution and less interference than Cat5e. What is the function of a switch in a data system? Why we use the switch? We use the switch to connect the devices on the network to be a one network. I have several devices, I need to connect it together, so I bring a switch to connect each devices to be one network. What is the function of patch panel? We use the patch panel to organize and connect network cable within the rack and facilitate network maintenance or modifications. It's organizing tool. We put it in the data rack. What's the difference between 4U and 40U rack? We know that the rack we use it, the rack or the cabinet we use it to organize the network equipment like switch, routers, recorders, servers. And the 4U rack is small as used for simple project or small network. I told you that before. Patch panel need 1U, brush panel need 1U, switch need 1U, recorders need 1U. So 4U rack is small for the small project. Let's say for CCTV system only if I have one MVR, one switch and خلاص. But 42U rack is large and used in several rooms or large network. If I have big network, I can use 42U rack. So I think خلاص we finished the data network structure chapter.